Coming up on the FRC Open Alliance show, it's 5,000 Hammerheads out of Massachusetts on to give us their updates on what they've been working on so far. We'll be diving into their prototyping with their climber and turret, and diving a lot more into their CAD process right now. You're going to see a screen share and showcasing what they've come up with so far from their frame, indexer, packaging, and different coaxial stuff as well too. And then we're going to be diving a little bit more into their code and what they're working on, specifically in shooter calculations and a really cool simulation to show as well too. So let's learn about their progress coming up here on the FRC Open Alliance show. This video on fun is brought to you by our viewers, supporters, members, and also in partnership with the following. AndyMark provides superior service and reliability that teams expect at andymark.com. From the Robotics Launcher Expansion Kit to the SDS MK4 and 5 Swerve modules, your team can be ready for rebuild. Don't forget to stock up on game-specific elements, bumper kits, and new for 2026 products at andymark.com. Osh Cut is a premier metal cutting service for first teams. No minimum order, options for same-day turnaround, guaranteed lead times, and instant online quotes. Osh Cut is offering first teams 50% off any future order up to $200 when you scan the QR code or go to funroboticsnetwork.com/OSHCUT. Just upload a 3D model or flat pattern to get started. Let's welcome into the Open Alliance show. It's 5,000 Hammerheads coming in out of Massachusetts. Welcome, everybody. We're excited to talk about your progress. Been some great stuff in your build log. I know stuff with climbers, prototyping, code, and more. So why don't you two introduce yourselves, listen to what you do on the team, and let's hop right into it.
Yeah, so I'm Tori. I'm the code captain.
My name's Logan. I'm the CAD and build captain. So we really got started initially with our climbing prototype because we knew that our robot would have to revolve around the climber kind of because of how like intrusive that would be. We initially started trying to figure out a way to do a dual jointed climber, which would allow us to potentially hit L3, which it did work, but kind of. And then we moved on to a sort of a latching mechanism climber. And then after we did this within the first few days, we started to do more strategy analysis when we figured out that it might actually not be worth it for us to be able to make a super intrusive climber that would potentially hinder the rest of our robot and the performance and the size, because we realized that we would have to stay under 22 inches to be able to get underneath the trench, which we want to be able to do. So
especially in auto and stuff, throwing off that odometry could be really bad if you're going over the bump. Make sure that we're able to keep our paths consistent.
From there, we began the parallel prototype. We went down this one rabbit hole of trying to do a minimal climber that would be able to use wheels. And you can see it actually doesn't take too much torque to be able to wheel your robot up the side of the up the side of the tower. However, what we did realize was the amount of time that would be to align and get yourself perfect on there. So we decided to pivot away from that and go with some more non-intrusive climbers, which I will show in a bit on the CAD. From there, we went into turret testing, where this is a video of us last night, and we began to get that turret going. When we initially started prototyping it, we did a 3D printed little jig, and we actually kind of nailed the compressions first try.
I think I sent a video of that too.
Oh, did you?
Yeah.
Of
the like initial kickoff day on kickoff, we got that first try. Crazy good guess by Logan, I think.
Yeah, so we got those compressions right. So then immediately the next day I CAD'd up and got our we got our turret CAD up, and we got it so we could get it cut. So right now we just have the physical hood and stuff like that mounted onto a test jig, but we also have the rest of the turret stuff for once we begin building the rest of our robot. So right now that's our rendition 1 of it. By our first competition, which is week 3, we are going to do a full redesign of it, make it slightly shorter, make it fit better into our robot. But this will allow us to be able to have something so we can focus on the rest of our robot while still being able to get testing with code.
SRPP.
Yes. We'll get into SRPP. SRPP is a beautiful material. Can
we talk a little bit about just some of the priorities from your team? So obviously, you're looking at doing a climber, you do a lot of training. How did some of that strategy process go just to determine that that's the route you wanted to go?
I think, I can talk about this. So with kind of deciding what we would want to do with the climber, I think, I mean, initially, like Logan said, we were really thinking that L3 climb would be super important, specifically on the side of like thinking kind of back to last year of how important the deep climb was and having like 3 teams being able to do that, both for ranking points and just the raw points in playoffs. And kind of we were initially kind of going for the hardest climb, so that you could have a triple traversal, but we realized that it's just really not worth the points, in terms of like actually in the match, as well as the time investment we have to spend and the amount of space we take up on the robot. So what we kind of pivoted to is thinking about just a really super fast L1 climb that we can do both at the end of auto and at the end game.
Yep.
And the point of it is you can get 15 points at the end of auto, 10 points at the end of teleop. And if you have 2 rows that can do that, then you get a ranking point. And it would take up so much less time than getting up to L3 that it really just makes it all a whole lot more worth it.
On that note, we went down a whole rabbit hole, which we still might go down in the future, of using a gas strut to be able to climb. So you could do a post buzzer climber. So this was inspired by 88's climber from last year, where they had a gas strut that they would winch up. It was about 700-pound gas strut. They would winch it up, and then at the end of the competition, or at the end of the match, when your motors were disabled, all power was cut, it would release the gas strut so you climb after the buzzer ended. Went down a whole rabbit hole on that. I have geometry that would work for, but we decided to put a pause on that right now and just go for a super fast regular climber, which I'll show. I can get into the CAD. Is there anything else I want to talk
Or did you want to talk about prototyping a bit more?
we'll do that with CAD.
Oh yeah.
So
CAD.
initially, so one of our biggest things that we had for our robot was that we want to have 2 intakes. That is, for us, in our opinion, going to be really, really advantageous. It'll be a huge strategic advantage. There's going to be so many balls on your side of the field. Being able to intake literally without rotating your robot more than 90 degrees is going to save you a bunch of time, and it'll be really helpful. The other benefit of it is it gives us sort of a dual expandable hopper sort of situation, which we'll get into. But you can only extend one at a time, so kind of get the same thing. The climbing stuff, our current plan is to have hooks that pop out. We just prototyped this and tested this about 10 minutes ago, and it does work. Hooks pop out using some surgical tubing, and then you winch them down with your climbing when you climb. We're also going to do some latching mechanisms such that it'll latch in place when you do a full climb at the end of the match, so that way you can hold your robot in place. But then at the end of auto, it won't fully latch in. That way, by the time teleop starts, your robot should hopefully be back on the ground. So now, if we talk about some of we'll get into the turret right now.
I want to say general design and like
what
we do it.
So for our general design, we have 2 deployable intakes on rack and pinions. These are going to be made out of SRPP. We're going to do some initial prototyping in polycarb because we have a polycarbonate sponsor, so that's free for us and a lot cheaper. But final will be SRPP because we used that in the off season last season and fell in love with it. They are going to deploy out with some polycarbonate panels on the front, so it gives you a functionally expandable hopper. Still have to do a little bit more work on the design of the hopper, but it will give us a expandable hopper so we can keep it out and store more. And
specifically, in terms of like kind of what we're using that for is at the end of an inactive period, or like at the end of auto or something like that. We're in the center and we're coming back. You open one intake and you keep the other closed, like no matter what. You just fill up your hopper and you've that expended space, so that when you get back to your side and the active period starts, you can just shoot more balls than you would be able to if you were confined to the initial robot volume.
What sort of material are you looking at using for the that rack and pinion area of the arms coming out, actually? That's
going to be all SRPP.
Okay, cool.
So it's modeled as carbon fiber, but SRPP looks very similar, so that's why I chose that material. So it'll be super durable to side impacts and stuff like that. which is really important, while also being rigid.
And also part of the reason we did a linear slide is because if we take a head-on collision,
Yep.
it's gonna more backdrive the motor than put stress on the material, ideally. And that was an issue we had last year where I guess I would like ram the intake into the reef a lot of the time, and that was not great for the intake's integrity.
Another benefit of doing our rack and pinion is how tightly we're able to package everything. You can actually see between the 2 intakes and the climber over here, it ends up only taking about 1.5 inches of the robot space. I can get you the exact number.
Yeah, the
About a little
packaging
bit less
just
than
looks
1.5
very
inches.
slick on that. That's really cool.
So everything's super tightly packed and on the side, while maximizing your internal volume. We still have to do some work on we're going to be doing a 125 inspired Spindexer idea
From Steam.
from Steamworks from 2017. And I'll get more to that in a second. But doing all that will really maximize our internal volume of the robot. Our turret will end up being mounted onto some carbon fiber rails. We chose carbon fiber because, as it turns out, the length that we needed, it wasn't really that much more expensive to order them from West Coast instead of aluminum. And carbon fiber is really cool. And they're also light, which is helpful. So our turret will be mounted on that with a Spindexer beneath it. But initially what we had was a similar rack and pinion method with a large amount of wheels that's fed in using the sloped sort of thing. We quickly decided to pivot away from that just because of the lack of storage space that would give us for storing all of the fuel.
And also how it probably wouldn't be as fast.
Yes, that too. But with the Spindexer, we're working on some of the geometry right now for that. But it should work with a 21-inch diameter drum, basically. So with that, it led us to choose a weird frame size of 28.75 by 26.25. Something that teams are actively questioning our decisions on doing is using instead of doing a standard box tube frame. So you can see we're doing a 1/4-inch machine frame.
Yeah.
It allows us to be able to do a lot tighter packing of everything, including the rack and pinions and the climber, while also still, in theory, giving us the same structural integrity. What we plan on doing is adding functionally a diagonal 1x1 cross support going through it, creating a giant triangle, giving us room for mounting our Spindexer in the middle while still keeping everything super low. The name of the game this year for us has been integrating as many mechanisms together to be able to maximize internal volume for the fuel, while also still ensuring reliability and upgrade path.
So before we get into your shooter itself, and then of course I want to dive a bit more into some of the code work you've been doing too. What is your target like fuel per second for that Spindexer? Like how quickly do you want to get that out?
So initially we had targeted around 4 fuel per second.
It's like a base.
As a base. And then we quickly realized that hopefully with this new Spindexer, stuff like that, we'll hopefully be getting 8 to 12 fuel per second.
Yeah.
Obviously, we want our limiting factor to be our intakes, not our indexer and our shooter, because the intakes are going to be the easiest thing to upgrade. So making the indexer and our shooter as fast as possible will be the name of the game early on. And then between competitions, we can run updates or we can run upgrades on our intakes to be able to make those things intake faster. At some point, though, there will always be a bottleneck. The goal is to make that bottleneck as fixable as possible. With our Spindexer, however, something that we are doing is we are going to be making it coaxial. So this is currently all I have in right now. But yeah, so in the off season of last year, I worked on this coaxial turret. I did a lot of talking about it on Chief Delphi, so you can find that. But using these same principles, basically what it allows you to do is it's like a swerve basically, but for a turret in this case.
Sure.
The same principles will be used for our Spindexer, and then hopefully down the line, with a Rev 3 of our turret, all in doing the same thing, which allows you to functionally have infinite rotations of your turret without having to worry about a cable chain
Or a slipper.
or a slip ring. The other thing, I don't think there's anything else from that. The other thing that's important for us with the design is to make it as upgradable as possible while still integrating everything together. So making sure to leave room for potential upgrades that we just don't have the time to research and develop right now. We're also working on our camera placement. Currently, we are thinking about running about 6 cameras with 2 orange pies. We would have 2 of them. Well, basically, we would. Our plan is to corner mount them. So we'd have one pointing out sort of this direction, one pointing out this way, and mirrored, and then we put 2 pointing out to the sides. Hopefully, give us 360-degree field of view of everything around us, and not give us the option to not put a camera on the turret. So to that, we can go over to code, which has a bunch of cool stuff.
Yeah. I guess a thing I want to mention first with the code is that I've been kind of trying out, maybe beta testing, this library I wrote in the off-season, mini library called Tunable Controls, which I have posted on Chief Delphi as well. And I found that to be really useful. It basically provides a super simple way to do tuning of both PID and feed forward using Advantage Kit. Because I found in the past that just publishing a PID controller to a smart dashboard can work for tuning the P, I, and D, but then you can't necessarily tune the feed forward values. And so that has been really helpful, especially just getting this simulation set up. The flywheel PID is all right. Most of the errors that when the balls don't make it in are because of that. But being able to get that, I took maybe a minute to tune that because it was super easy to do with that. And that kind of goes into the shooter calculations, which I've been iterating on quite a bit, just mostly using simulation and Desmos. Very useful. So initially, we were thinking, and kind of came back to this in the end as well, is controlling the arc of the balls through 3 points: the robot, the hub, and then a point that is 20 inches above the funnel. And that lets it be a very consistent arc going into the hub so that we're not hitting the funnel going in, not too shallow, while also hopefully not being too steep of an arc that our balls are colliding in the air too much. So I built that, and then I kind of switched over to trying to use a more or less constant velocity, or not constant, but not fast changing flywheel velocity. And that worked pretty well as well when you were stationary. But then I found that when you tried to move, it required a lot more speed than we had using just the slow moving flywheel. And I realized that I really could get away with changing the flywheel speed faster than I was thinking.
And on that note, another thing that we currently have on our turret is that we can control both the front wheels and the back wheels separately currently for initial testing. And by the final revision of the turret, I believe our goal will be to figure out the optimal gear ratio for the difference between the 2 flywheels, and be able to actually drive both. Use 2 Krakens to drive both wheels simultaneously, so that way we can have a smaller inertia flywheel on the side and be able to be able to adapt our flywheel speed a lot faster. Yeah.
I guess just important point to touch on is shooting while moving, which is arguably the biggest code challenge this game, I think, because there really isn't a closed form solution to figure out what speeds you should use. So I think what I'm doing, like a lot of other teams, I know Mechanical's doing a similar thing, is using basically a look ahead where it will estimate the time of flight for a stationary shot, and then basically project the hub that far in the future with the robot's velocity. and target that. And then I think something I'm doing that I'm sure other teams are doing it, but I haven't seen any other team doing it yet, is iterating that multiple times. So currently that's going through 3 iterations, but I can change that number. And that means that I found it to be a lot more consistent than just having the one, because the flight time changes when you do the second test and all of that. But that's kind of in the video of the simulation, that yellow arc is the arc that it's basically calculating that it should have if all of the mechanisms were meeting their goals properly. And then the fuel that's shooting is like what they're actually be doing, just because of the simulation not being perfectly tuned and everything. But I think that's really just been super helpful to have the simulation. It's really something I started doing last year, a bit later in the season, and especially switching over to Advantage Kit in the off season has helped a lot with getting simulation really nice. I mean, I got the 3D model in there, which I really like, but it's not strictly necessary. But being able to test that out, those calculations, I really wouldn't have been able to do last year until we had pretty much everything built. And this also lets us do auto paths and all of that, which is very helpful.
Well, 5,000, this is a lot of great stuff to digest, I think, for teams to go through, and make sure you are tuning into their build log on Chief Delphi as well, too, to see all their progress well. But really appreciate you taking the time. I had some great in-depth things for teams to look through and consider for themselves as well, too. So we appreciate all the efforts that you put into it as well. So good luck the rest of the way. We'll see you back on here in just a few short weeks, and we can't wait to see your continued progress. Thanks a lot.
Thank you.
Thank you so much.
Thanks for watching. Don't forget to like, subscribe, and click the bell to stay up to date on future fun videos. Osh Cut is a premier metal cutting service for first teams. No minimum order, options for same-day turnaround, guaranteed lead times, and instant online quotes. Osh Cut is offering first teams 50% off any future order up to $200 when you scan the QR code or go to funroboticsnetwork.com/OSHCUT. Just upload a 3D model or flat pattern to get started. AndyMark provides superior service and reliability that teams expect at AndyMark.com. From the Robotics Launcher Expansion Kit to the SDS MK4 and 5 Swerve modules, your team can be ready for rebuild. Don't forget to stock up on game-specific elements, bumper kits, and new for 2026 products at AndyMark.com.